Hello everyone, I welcome you all to Academy, where you can aim for higher goals, aware of those goals, and achieve them through Academy. Academy is for you to take the right decision, to move in the right direction, and to reach at the right destination. In today's lecture, we are going to learn how to design surface-based spherical periodic lattices. Okay, so here we have the spherical coordinate system, and with respect to that, we have spherical shape, spherical like a spherical space. Within that, we are going to incorporate our TPMS based unit cells and trying to generate or trying to design the spherical periodic lattice structures. Okay, so let's start designing them. So first we have to give the file name as TPMS based spherical periodic lattice structures, and we can add the description as the design of TPMS based spherical periodic lattice structures. Okay, and our section name as TPMS spherical lattices, spherical periodic lattices. Okay, so for this, first in our first step, we have to define periodic lattices. So we can get it from either we can get it from like a lattices block, and there we can go to the lattice tab, and here we can select the periodic lattice. We have selected it. As I said that we can get it from two different ways. Either we can search from here or we can directly get it from here. Okay, now now we can, yeah, within periodic lattice, what do we observe? We observe that we have to define three geometrical parameters. One is unit cell, second is cell map, and third is unit cell parameter. This third unit cell parameter, this third unit cell parameter is directly depending on the unit cell, the type of unit cell we are going to use. So it can be anything. So in today's lecture, our aim is to design TPMS lattices. So this unit cell parameter is mainly depending on the type of TPMS we are going to use. Okay, so let's define them one by one. The first parameter is unit cell. So what is our goal? So we need to design TPMS lattice structure. Now. So let's select the TPMS unit cell. How can we get it? Either we can directly get it from here only. In nTopology, so there is a specific term like TPMS unit cells. Okay, walled TPMS unit cells. Okay, so either we can select any one of them. So I'm going to select either we can select, get those parameters or those blocks directly from here itself, or we can go to the unit cell tab within the lattice tab. So from here also we can get it. Here we have different type of unit cells, isn't it? So from this we can select one of the TPMS type, that is TPMS unit cell with offset. So let's select this. Yes, what do we observe here? Again, it has two different geometrical parameters. One is the unit cell, another one is orientation of it. So let's define them. Let's define one by one. Okay, so first one is type of unit cell we are going to use. So let's see, select this. So in nTopology, by default we have total 6 TPMS unit cells. So we can select any one of them, and we can we can change it later. So for time being, we can select gyroid unit cell. What do we observe here? So this is our gyroid unit cell. So with it is in cubic shape, means within the bounding box of cube, and it has a local coordinates, local axis such as u, v, w, and the global axis such as x, y, z. Okay, this is our unit cell. So if somebody wants to check its dimension, they can check it directly from here. So let's press select it from here to here. So it means it is approximately, it is 10 mm size unit cell by default. Okay, now we need to place, yeah, we need to place this within the unit cell block. If somebody wants to give the orientation, they can give it, but as I said in most of the videos, most of the previous lectures, there is no effect of your orientation for cubic unit cells. Okay, it has only effect on 2D unit cells or 2.5D unit cells and any asymmetric unit cells or any asymmetric geometries. So let's minimize this. So if we have defined our first parameter of unit cell, now we are going to define the cell map. So as we are focusing on the spherical cell map, so let's get it. Either we can get it from here, spherical cell map, or we can get it from here as well, or we can get it from by searching from here. So let's get it from here, spherical cell map. Yeah, what do we observe here also? Again, it has total 6 geometrical parameters we need to define. So let's define one by one. First, we have to define the volume we are going to use for generating the means a spherical cell map. So, and second, we need to define the radius of cell and the latitude count and longitude count. So, let's define the volume first. For this, we can go to the create tab and select the primitive tab. From here, we can select any one of the shape. So, in today's lecture, we are going to select the sphere. Yeah. Now, sphere has an equal diameter of size of the unit cell. So, let's keep it as, let's minimize, let's turn off the visibility of unit cell. Now what do we observe here? Again, sphere has two different geometry parameters. One is point, its midpoint, center point, and one is its radius. If somebody wants to tune the radius, suppose 10 mm, they can simply 10 mm. If somebody wants to use it 2 mm, 2 mm, it's up to you. So in today's, now we will go as it is 5 mm. Okay. Let's place this within the volume. Okay. Now let's minimize this. Let's define the, let's expand it. Let's define the cell radius. Let's define the cell radius as 2 mm or 1 mm, and latitude count as 4 mm, the number 4, not 4 mm, and longitude count as 4. So this is our spherical cell map. Okay, this is the preview of spherical cell map. Let's uh, our gyroid unit cell is going to incorporate within this periodic lattice of spherical shape. So uh, this frame, if somebody wants to define it, they can define it, but in today's lecture we are not going to define it. So let's keep as it is. Now we can place, yeah, here there is one more term that is called linear. Here if you see this, these beams, these lines are like curved. If I choose them as a linear one, then they can become the linear, isn't it? Yeah, this is the difference. So let's go with the curved one only, and let's see what is going to happen. Let's place this spherical cell map within the cell map we have generated. Now, till now, we defined two major two geometry parameters. One is unit cell type and another one is cell map. Now, the third geometry parameter, that is mid surface offset. As I said, the term earlier we have unit cell parameter one, but it is now changed into mid surface offset. Why? Because as I said, it is majorly depending on the type of unit cell we are going to use, isn't it? So that's why its name is depending on this unit cell. Now we need to define this as, suppose, 0.3 mm. Let's see what is going to happen. Yes, we have generated the our TPMS gyroid spherical periodic lattices. So it looks very beautiful and has a higher relative density. Let's see its cross section view, how exactly it does it. So this is how we can able to see it's a cut section view, and we can see different planes also. This is how it has a porous nature, and if somebody wants to change the mid surface thickness as 0.01, yeah, see, its density is reduced, isn't it? So this is how one can able to design different means like a gyroid spherical periodic lattice. So till this is okay, that's it. Now if suppose as we have six different types of unit cell, so if somebody wants to tune the unit cell also, then they can simply change the type of unit cell. Suppose let's go to the diamond unit cell and let's wait for it. See, look at this, how beautiful it is, isn't it? So this is how, and let's check its cross section view. Look at this, how beautiful it is. Circular ring, isn't it? So this is how one can be able to design different types of TPMS unit cell within the spherical cell map, and that too periodic in nature. So that's it. So till now, what we have learned? We have learned that how to create or how to design TPMS period cell spherical TPMS unit cell within the spherical cell map and generate the periodic lattices. Okay, for that initially we have selected the periodic lattice from the lattices tab, and then later on we have defined its independent parameters such as unit cells from here, and then we have defined the cell map from here, and then we have given the unit cell parameter. So I hope you understood, and I hope you have learned. So thank you, and keep learning. Bye.